On a 400 amp 240 volt 3-phase service, you can parallel the conductors between the meter and the main to increase the current carrying capacity. However, it is not always required. Paralleling conductors becomes necessary if the load exceeds the ampacity of a single conductor. When paralleling conductors, several factors must be considered to ensure compliance with the National Electrical Code and safe operation of the electrical system. Firstly, let's discuss conductor sizing. For a 400 amp 240 volt 3-phase service, the minimum conductor size is number 3 American wire gauge copper. If you choose to parallel conductors, it is imperative to use the same size conductors for all paralleled conductors. This ensures equal current distribution among the conductors. Secondly, consider the number of paralleled conductors. The specific number of conductors required depends on the load and the ampacity of the individual conductors selected. Consult the NEC tables to determine the appropriate ampacity for the chosen conductor size and insulation type. Ensure that the combined ampacity of the paralleled conductors meets or exceeds the total load requirement for the service. Thirdly, let's look at splicing. When paralleling conductors, all splices must be made in accordance with the applicable electrical code. This means using approved splicing methods and connectors that are properly rated for the conductor size and material. Ensure that all splices are mechanically secure and electrically continuous to minimize the risk of overheating or failure. A critical aspect of paralleling conductors is conduit fill. The conduit must not be filled to more than 40% of its cross-sectional area with conductors, including insulation and any necessary padding. This requirement is in place to facilitate heat dissipation and prevent overheating of the conductors. Refer to the NEC Chapter 9 tables to determine the maximum number of conductors allowed in a specific conduit size based on the conductor size, insulation type, and conduit type. Yes, you can use a common conduit nipple for the parallel conductors, provided that the nipple is large enough to accommodate the total cross-sectional area of the conductors plus any insulation or padding. The conduit must be sized appropriately to meet the conduit fill requirements outlined in the National Electrical Code. When selecting conductors for paralleling, choose conductors with the same material, for example, copper or aluminum. Using dissimilar metals can lead to corrosion and connection problems over time. Also, ensure that the conductors have the same insulation type and voltage rating. This will help maintain consistent performance and prevent insulation breakdown. All conductors must be terminated in the same manner. Use appropriately rated connectors or lugs that are specifically designed for paralleled conductors. Ensure that the connectors are properly torqued according to the manufacturer's instructions. Do not exceed the torque rating, as this can damage the connector and lead to connection failure. Consider the impact of voltage drop when paralleling conductors. Voltage drop occurs due to the resistance of the conductors and can affect the performance of electrical equipment. Paralleling conductors reduces the overall resistance of the circuit, thereby minimizing voltage drop. Calculate the expected voltage drop based on the conductor size, length, and load current. Verify that the voltage drop is within acceptable limits as specified by the NEC or other applicable standards. When installing parallel conductors, pay attention to the routing and physical arrangement of the conductors. Heap the conductors close together and ensure that they are evenly spaced to promote equal heat dissipation. Avoid sharp bends or kinks in the conductors, as these can increase resistance and create hot spots. Support the conductors properly using approved cable ties or supports to prevent strain on the connections. Grounding is a vital consideration when paralleling conductors. Ensure that each conductor is properly grounded in accordance with the NEC requirements. Use appropriately sized grounding conductors and grounding electrodes to provide a low impedance path for fault currents. Verify that the grounding system is effectively bonded to all metal enclosures and equipment. Proper labeling is essential for identifying parallel conductors. Clearly label each conductor with its size, type, and function. This will help prevent confusion during maintenance or troubleshooting. Use approved labeling methods and materials that are resistant to fading or deterioration. Always consult the latest edition of the NEC and any other applicable local codes or regulations before installing or modifying electrical systems. The NEC provides detailed requirements and guidelines for paralleling conductors, as well as other aspects of electrical installations. Familiarize yourself with these requirements to ensure compliance and safety. If you are not experienced or qualified to perform electrical work, it is essential to hire a licensed electrician. Electrical work can be dangerous, and it is always best to leave it to the professionals. A qualified electrician will have the knowledge, skills, and tools necessary to perform the work safely and in accordance with the applicable codes and standards. Remember to always energize the circuit before working on electrical conductors. Use appropriate lockout/tagout procedures to prevent accidental re-energization. Verify that the circuit is de-energized using a voltage tester before touching any conductors. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. Regular inspection and maintenance are crucial for ensuring the long-term reliability of parallel conductor installations. Periodically inspect the conductors, connections, and supports for signs of damage, overheating, or corrosion. Tighten any loose connections and replace any damaged components as needed. Perform insulation resistance testing to verify the integrity of the conductors. Document all inspections and maintenance activities for future reference. Conductors in parallel must conform to NEC Section 310.10. This section outlines the requirements for conductors connected in parallel. Here's a more detailed breakdown. Firstly, conductors must be number 1/0 American wire gauge or larger. The NEC generally permits conductors size 1/0 American wire gauge and larger to be run in parallel. This requirement helps ensure that the conductors have sufficient size and ampacity to handle the load current safely. Secondly, the conductors must be the same length. All parallel conductors must be the same length to ensure equal current distribution. Differences in length can result in unequal impedance, leading to some conductors carrying more current than others, which can cause overheating and potential failure. Thirdly, the conductors must be of the same conductor material. Parallel conductors must be made of the same material, such as copper or aluminum. Mixing conductor materials can lead to corrosion and unequal current distribution due to differences in conductivity. Fourthly, the conductors must be the same size and circular mill area. The circular mill area of each parallel conductor must be the same. This ensures that each conductor has the same ampacity and contributes equally to carrying the total load current. Fifthly, the conductors must have the same insulation type. Parallel conductors must have the same insulation type. Different insulation types have varying temperature ratings and dielectric strengths, which can affect the performance and safety of the installation. Sixthly, the conductors must be terminated in the same manner. All parallel conductors must be terminated in the same manner using the same type of connectors or terminals. This ensures consistent and reliable connections that can withstand the load current and environmental conditions. Seventhly, equipment grounding conductors. Equipment grounding conductors must be run in parallel with the circuit conductors when installed in parallel. This ensures that a low impedance ground fault path is always available, which is essential for safety. Eighthly, bonding jumpers. Bonding jumpers must be installed in accordance with NEC requirements to ensure that all metal enclosures and equipment are properly bonded together. This helps to minimize the risk of electric shock and prevent the build-up of static electricity. Ninthly, conductor ampacity. The ampacity of each parallel conductor must be sufficient to carry its share of the total load current. Consult NEC tables to determine the appropriate ampacity for the conductor size, insulation type, and installation conditions. Tenthly, derating factors. Apply any necessary derating factors to the conductor ampacity based on the number of conductors in a raceway or cable, as well as the ambient temperature. Derating factors are used to reduce the ampacity of conductors to prevent overheating when they are installed in close proximity to each other or in high-temperature environment. 11thly, physical protection. Parallel conductors must be protected from physical damage. This can be achieved by installing them in rigid metal conduit, intermediate metal conduit, or other approved raceways. The raceway should be securely supported and protected from mechanical stress. 12th, conductor identification. Clearly identify all parallel conductors with appropriate markings or labels. This helps to prevent confusion during maintenance or troubleshooting. Use permanent markers or labels that are resistant to fading or deterioration. 13th, load calculations. Perform load calculations to determine the total load current for the circuit. This information is essential for selecting the appropriate conductor size and number of parallel conductors. Load calculations should be performed in accordance with NEC requirements and should take into account all connected loads. 14th, voltage drop. Evaluate the impact of voltage drop on the performance of electrical equipment. Voltage drop can cause equipment to operate inefficiently or malfunction. Parallel conductors can help to reduce voltage drop by reducing the overall impedance of the circuit. 15th, coordination. Coordinate the overcurrent protection devices with the conductor ampacity to ensure that the circuit is adequately protected from overloads and short circuits. Overcurrent protection devices, such as circuit breakers or fuses, should be selected and installed in accordance with NEC requirements. 16th, documentation. Document all aspects of the parallel conductor installation, including the conductor size, type, length, ampacity, and overcurrent protection device ratings. This documentation should be kept readily available for future reference. 17th, inspection. Have the parallel conductor installation inspected by a qualified electrical inspector to ensure compliance with the NEC and other applicable codes and standards. An inspection can help to identify any potential safety hazards or code violations. 18th, maintenance. Perform regular maintenance on the parallel conductor installation to ensure that it remains in good condition. This includes inspecting the conductors, connections, and overcurrent protection devices for signs of wear or damage. 19th, grounding electrode conductor. The grounding electrode conductor should be sized according to NEC Table 250.66, based on the size of the service entrance conductors. For parallel conductors, the size of the grounding electrode conductor is based on the equivalent size of the parallel conductors. 20th, neutral conductor. When using parallel conductors for a three-phase, four-wire system, the neutral conductor must be sized to carry the maximum unbalanced load. In some cases, the neutral conductor may need to be larger than the phase conductors to accommodate harmonic currents. 21st, surge protection. Consider installing surge protection devices to protect sensitive electronic equipment from voltage surges. Surge protection devices should be installed at the service entrance and at any other points where surges may enter the system. 22nd, short circuit current rating. Ensure that all equipment and conductors have a short circuit current rating sufficient to withstand the available fault current at the point of installation. The short circuit current rating is the maximum amount of current that the equipment or conductors can safely handle during a short circuit condition. 23rd, ambient temperature correction. Correct the ampacity of conductors for ambient temperatures above 30 degrees Celsius or 86 degrees Fahrenheit, as required by NEC Table 310.15. High ambient temperatures can reduce the ampacity of conductors, so it is important to apply the appropriate correction factors. 24th, raceway fill. Ensure that the raceway fill does not exceed the maximum allowable percentage specified in NEC Chapter 9, Table 1. Overfilling a raceway can restrict airflow and cause conductors to overheat. 25th, conductor support. Support conductors in accordance with NEC Section 314.23 to prevent strain on terminations and ensure proper alignment. Conductors should be supported at intervals that do not exceed the value specified in the NEC. 26th, conductor bending radius. Maintain the minimum bending radius specified by the conductor manufacturer to avoid damaging the conductor insulation. Sharp bends can damage the insulation and reduce the ampacity of the conductor. 27th, torque requirements. Torque all connections to the manufacturer's specifications using a calibrated torque wrench. Under-tightened connections can overheat and fail, while over-tightened connections can damage the connector or conductor. 28thly, harmonic currents. Consider the impact of harmonic currents on the neutral conductor and other system components. Harmonic currents can cause overheating and equipment malfunction. If harmonic currents are present, it may be necessary to oversize the neutral conductor or install harmonic filters. 29thly, emergency systems. For emergency systems, parallel conductors should be installed in separate raceways to provide redundancy and prevent a single point of failure. This ensures that the emergency system will continue to operate even if one raceway is damaged. 30thly, fire stopping. Fire stop any penetrations through fire-rated walls or floors to maintain the integrity of the fire barrier. Fire stopping material should be listed for the specific type of penetration and construction. 31stly, labeling at each end. Label each end of the parallel conductors with the circuit number and the phase designation. This helps to prevent confusion during maintenance or troubleshooting. 32ndly, record keeping. Maintain accurate records of all parallel conductor installations, including conductor sizes, lengths, ampacities, and overcurrent protection device ratings. These records should be kept readily available for future reference. By following these guidelines and consulting the NEC, you can ensure that parallel conductor installations are safe, reliable, and compliant with applicable codes and standards.